I want to get all the rest of the noise out of this 64 twin, and it's almost all on the vibrato channel. The normal channel, aside from some static on the volume pot, is pretty good. And that static is not caused by DC on the pot. I think that's just the pot. And that same behavior is there, but worse, on the vibrato channel volume pot. And that's with different tubes. A little bit microphonics on this tube, but we'll sort that out. That's a separate issue. This noise is there with different tubes in place. So we power the amp off, and I'm going to take this knob off. And we're going to try a different volume pot and see if that solves the problem. This knob wants to come off. There it goes. All right. Let's see if I can do this without hitting the tripod 10 times in the process. I want to disconnect the two solder joints at that volume pot. So there's the wiper connection. Bend that down a little bit so it's more visible to us. And the original joint is not wrapped or anything. It'll just pull right out once I get the solder warmed up. All right. Let's steer this wire out of our way. And then there's a connection here to the input, which is coming from the treble wiper. And then there's the bright cap, which I've already replaced because the old one was measuring about 50 picofarad rather than the proper 120. Let me get some of that excess solder off that cap. Now, I have powered the amp off, but I've not discharged the caps. I am actually turning off the power to the amp, so if I were to touch something in this area accidentally, I won't zap myself. But the amp has been powered off now for a minute or two, and I did not drain the caps. Let's see what DC voltage is still present here, to see if there's any gotchas lurking for us before I do any other work. 8 volts. All right, 8 volts I can handle. But sometimes they'll store a lot more than that. And it's just something to be aware of and careful of, because if there was more than 8 volts and I were to touch right here, I could get zapped. All right, so those connections are undone. And let me find the proper socket wrench. Now, in the past, changing volume pots like this has solved a lot of mystery problems in these amps, because as good a quality pot as they used originally, it is a 50-something, almost 60-year-old potentiometer. And all a potentiometer really is a resistor that you can tap in different points of its resistive path. And like any carbon resistor, they can get noisy over the years, even though it measures okay. Let's see what it actually measures. It's supposed to be a 1 meg. It can measure fine and have no DC on it and still be a source of noise. Not just that scratchiness. It measures 1.076 megs. Not just the scratchiness, but actual in the background. And here I've got a CTS. It's supposed to be a 35% J taper pot. Let's do some measurements on it as well. And we'll compare some measurements to the original. Some of you might find this interesting. All right, now a J taper pot means that it should give 20 to 30% of its total value when it's at noon. And how do you know when it's at noon? Well, this is not the most scientific method, but it works well enough for this application. I have the old pot here at minimum. Put a little mark lining up with that lug, which is one extreme of its rotation. And I'll do the same thing for the new one. Is this precise? No. But no one ever turned the knob exactly precisely in the real world. This will tell us how well these pots compare to each other. So here's the new one. I will turn it to noon. And the original, turn it to noon. And this one measured 1.07 something meg across its lugs. The new one measures 0.955. That's well within tolerance. You're not going to hear any real difference between a 1.07 and a 9.9 something in the circuit, 0.955. But what does matter for our purposes is the value at noon. So at noon, this one, which is 955, measures 265, and the original one, which was right up over meg, measures 183. So this one at noon was about 18.3% of its value, of the rated value, and this one, the new one, is about 26%. So this one's actually closer to the spec on the schematic. So this will behave as Leo intended. One other consideration when changing these pots, you can see the new pot has got a longer bushing, which means I need to use more than one toothed washer to get it the same from the faceplate. This is much easier to do when I don't have the camera right where my hand would normally go. All right, that's kind of lined up perfectly on the faceplate. But before I put that in place, let me take these washers off. I want to make our ground lug connection. On this amp, the 64, the ground on the volume is made to the pot casing. So it's real crucial that we get a very good connection to the chassis. And this one has that nice brass bushing. This is a good quality pot. And unlike the 10% A tapers, that's 1 megs that CTS makes, which have a tendency to just drop out below 9 o'clock. There's just, from 9 o'clock to 7 o'clock, sometimes there's just nothing, and all of a sudden it just goes on. These usually work very well. But I want to prepare the ground before I do it. All right, so I want to make one bend like that, kind of at an angle. Then bend the whole thing over. Then make the angle stronger, both to match the radius of the pot and so it'll line up when everything is pressed down. Now this is the part where you have to be careful not to actually fracture anything here. I want this to be flush against itself, so I'm pinching metal to metal, not putting pressure directly on the phenolic part. And that looks pretty darn good. Now I'll push this way, because I don't want the pot to be holding this in place. I want this to be where it needs to be before. I don't want the solder, rather. I don't want the solder to be forcing this to be here. I want this metal to want to be in this location before any solder is applied. That gives a very reliable ground. And is that a ticky-tacky little detail? Yeah, but the entire amp, every amp, which is great, is a whole cumulative effect of little bitty details that were gotten right. Speaking of getting it right, when you have more than one toothed washer, sometimes it's hard for them to catch where you want because they'll fight against each other. We're gonna see how we do here. Sometimes you gotta rotate things a little bit to get everything to line up just so you can get it nice and tight. Because in this case, this lug going to the shell of the case being connected tightly to the brass panel of the chassis gives us our ground for that node and gives us our ground grid reference for V2A. And it's really critical that be as good as possible. Later Fenders, I think some point in 65, they went to a physical wire soldered both to the brass strip and to this rather than doing it to the pots, which is better. But this usually works fine in a low gain amp like a Fender Twin, as long as you do it right. And I'm getting this really, cranking this really tight. I don't want this to come loose in the slightest. All right, now that is very tight. And now I will solder that connection because it's much easier to do it when it's held in place by the chassis than trying to hold it in my hand. It would get very hot. And because that metal wanted to be there before I soldered it, there was no flexing. It did not move while it was cooling, and there's no graininess to it. I'm just getting off a little bit of excess flux. And that should be very good. So let's redo these connections. I'm just going to kind of do a quick temp connection for everything to make sure, to see if the problem's gone. If the problem's still there and the volume pot made no difference, I'll put the original one back. The CTS prongs need to be bent down to reach. Not prongs, lugs. Sorry, when doing the videos, I'm thinking about larger issues or how to communicate something difficult. And I often mess up on the simple stuff like basic terms. I'll call a resistor a capacitor. I'll call an EL34 and EL84 like I did in that Laney video yesterday, much to my chagrin. Or I'll say prong instead of lug or eyelet instead of turret. And I'm sorry about that. These things are not scripted. If they were scripted, they'd be perfect and they would take way longer to make and I would never get around to making anything. I'm trying to talk about more important things. I'm just going to do a really fast, almost tack solder on these, which is, in fairness, what they did from the factory. And if everything's good and this pot fixes that problem, I'll go back and do some mechanical crimps as well, which again, they did not do originally, but I think it is better. I want to get this support on this. And yes, this pot extends farther from the chassis than the originals. There's no hiding that it is a new pot. But if it solves the noise problems we were having, who freaking cares? The original pot will be returned with the amp in case some crazy collector wants the noisy original. You know, if this turns out to be noisy. Put the knob back in place just so that I don't have any noise caused by touching the damn thing. Let's see, on this one, they changed the location on the set screws compared to later ones. On these 64s, it's better to line up at the 10. On later amps with those knobs, it's better to line it up at the 1. Starting with the volume at 0, I've got treble, middle, and bass all at 6.5, so noon, and I've got the reverb off because it would just add extraneous artificial noise to this test. Let's take it out of standby. Better. There's still a little bit of sound. All right, it is a lower noise floor than it was. I'm not convinced that this new volume pot was necessary. And the original may go back once we do the next thing. And the next thing I want to look at are the plate resistors for this vibrato channel first stage. There's a whine in the background, an oscillation that has never been there before. That's interesting. Let's see if moving wires affects that. I don't know if you can hear that, but I can hear it. Yeah, it's like a tea kettle whistle. Now it's gone. Sorry about that. A little bit of instability. Remember, this is the amp that was plagued by all the leaking DC in the wires. I've cleaned that up. But now we're going to turn our attention to the circuit for V2. That's the first and second gain stage for the vibrato channel. As I turn the volume for that channel up and down, I'm going to take it out of standby. We have that static. And that can be a problem with the bias of one or both triodes in this tube stage. That could also be a problem with the plate resistors. There are 3 plate resistors. This is for the first stage. This is for the second stage. Before I do anything like that, I want to rule out the possibility the problem actually is in V1, because V1B shares a cathode, resistor, and bypass cap with V2B. So I'm putting the amp on standby. I'm going to physically remove V1, which means that that tube and its plates and its loading will no longer affect V2. Is the noise still there in V2? Yeah, and I can hear that tea kettle. Some microphonics on the board that was not there before. And it's certainly audible in that tube. This is the kind of stuff that drives you nuts, because you play whack-a-mole. You're trying to solve a problem that in a newer amp would probably just be one problem, one part or one thing going wrong. And in amps like this, you can have 2 or 3 things which are all interacting, causing the same problem. You know, it's one of those things, it doesn't take long to change a part in a twin reverb. But in a 64, I don't want to change anything that does not really need to be changed. So I'd rather spend the time doing stuff like this than just shotgunning things or changing parts instantly. Getting the tea kettle still. We may end up having to shield the cables from input jacks and the volume. We had a whole bunch of stuff in this amp that was noisy beneath and between the boards, and that might be affecting what's on these 2 grids. And I can move this wire and make that come and go. So before I change anything else out in this amp, we power that off. I'm going to temporarily make a new run from the new volume pot to V2B's grid, because if there's a problem with this wire beneath the board, that will eliminate it. So just one second. Okay, I have temped in a wire, as you can see, from the grid of V2B to the switch, the bright switch of the volume, which is how it's connected originally in this amp. And I'm about to see if that made a difference. And I just wanted to take a moment to say something. If you're looking at this video and you haven't seen previous couple of hundred Fender videos I've done, you may think that I'm going really slow, or that I don't know what I'm doing, or I'm just trying to blindly stumble onto what it is. You know, there was a guy who commented on the chat speaker wiring, it took you 5 minutes to solder 2 wires for a speaker? No, it would take me a minute to solder 2 wires perfectly on a speaker. It takes 5 minutes to do a video on it and explain to you all the stuff that you have to take into consideration if you want to do a good job. And if you want really fast, sloppy work, the world is full of that. Watch some other channel. I can do all this stuff much faster if I'm not trying to explain. That's part of it. The other part is this is a very rare early 64 twin reverb that has the AA763 power section and tube chart in the cabinet, and it's in immaculate shape. And a lot of techs would have heard that noise that we just all heard, the rushing water noise, and then immediately started changing out all these resistors and putting in metal films and all this nonsense. And at the end of that process, you may have a quiet amp, but how much is it still an early 64 twin reverb versus just another twin reverb? So I have not changed these resistors. I have not done anything modern in here. In fact, I took out some modern components previously in this video series on this amp and put in things which are as close to the original components as possible. So let's turn this volume pot up now that we have a new wire and that this wire is out of the way. This grid wire was extremely microphonic. We've already had problems with gunk beneath this board in this amp already, and we had that oscillation. Let's see how this sounds. All right, that rushing water is gone. And that hum that you hear, that's from me coming closer or farther to things. Now here's an interesting thing. This grid wire is not connected at either end, but if I touch it, everything gets noisy. It's because it's running parallel to this grid wire, which is still original. If I put shielding on top of this amp right now, let me use this one from a Marshall to emulate how the amp would be when it's in the cabinet with that metal mesh on top. The rushing water is gone. You still have white noise, but all the hum and buzz is gone. So there's not a problem with those resistors. Someone else asked in a different video, I think yesterday, on the 66 Fiberlux, why I didn't just replace carbon composite resistors with metal films, because there's a million forums telling you to do that. A metal film resistor of the same value and wattage as a carbon composite is a much quieter resistor as far as self-noise and thermal noise and all kinds of things. And a carbon film, as far as noise goes, is in between a metal film and a carbon composite. And then metal oxides tend to be towards the metal film end of things. We're not going to get into inductance and things like that in this. But the sound of various resistor materials is different. Now, if I change out, assuming that this plate resistor is not noisy, which it is not in this particular amp, if I change out this 100K carbon composite for a carbon film or a metal film, or a metal oxide even, you're not going to hear any difference really in the amp. But if I change out 3, if I change out 5, if I change out 10, you cumulatively will begin to hear a difference. And I'm not going to say whether that difference is better or worse. It's not a good or bad difference. It is a subjective difference, which is measurable and observable. And some people would probably love the sound of this amp if I took everything out and put in carbon films or metal films. But this is a very rare 64 twin reverb, which has the original very nice quality carbon composites, and they're not exhibiting any problems. So I'm not going to change them unless there's a need to. A lot of guys would have changed out this cap when we had that initial DC issue. They would have changed out all this stuff, chasing down that noise. A lot of these resistors would have gone in the last 15 minutes of this video just because there was a noise that could be traced to this node. I don't like to change things that I don't have to change. But this does need to be changed. And this red one going to V2A is not much better. So what I'm going to do is I'm going to remove the red and yellow grid wires from the amp. And I'm going to run some shielded wire from the input and from the volume pot. I'm going to physically run it beneath the insulator board to V2A and V2B. And all those noises are going to go away while leaving all the vintage stuff. If you believe in mojo, here it all is. The mojo will be there, but the rushing water noise will be gone. And I'm also going to try this setup now with the old volume pot back in place and see if the problem was with the old volume pot. And then I will repeat. Probably have to change out the grid wires on the normal channel as well, because we did have a little bit of rushing water there. And if I can put that original pot back in, everyone will be very happy. So let me get set up to do that, and I will report back. Okay, taking out a standby. Got the original volume pot back in place, still with this Tim10 new grid wire. Before I go to all the trouble of putting in the shielded wire, I want to make sure the old pot is okay. I have the bright cap disconnected for right now because it's not necessary for this part. All right, the old pot has got a little bit, tiny little bit of the rushing water scratchy sound. I'm trying to make a judgment call as to whether that warrants replacement or not. I'm leaning towards not. I'll try it with the shielding in place so my hand's not contributing to everything. No. All right. With the shielding really well held in place so that my hand does not cause any interference here. That slight bit of sound as you turn the pot is not a problem, because you're not going to be doing that while playing. You're going to set it to 3 or 4 or 7, wherever you set it. So, time to replace the grids with shielding, and that will take away the rushing water sound in both channels and should lower the white noise quite a bit as well. So, while leaving everything on the board as vintage as possible. Okay, so the old yellow and red grid wires are out, no longer running through the board. Got shielded wire from the input on the normal channel to V1A, shielded wire from the volume on the normal channel to V1B. Same thing for the input jack and volume on the reverb channel, the vibrato channel, to V2, A and B. And all the rushing water stuff is gone. The original pots are, well, this one, the original pot's back, this one never left. And some of the noise that you might have just heard is because I was reaching over the chassis with my hand, and that caused a capacitance thing. When the shield's in place, it almost entirely goes away. Between the shielding here and the shielding on the wires, the self noise, the white noise, is greatly diminished as well. So, remaining issues with this amp, and this is something that I won't know for sure whether it's a real problem until I get this back in the cabinet. The microphonic power tube, which I've discussed before in videos on this amp. But, and then you can hear that when I do this. But I've tapped on all the preamp tubes, and I've tapped on the board, and the only microphonics left are in the output tubes. Let's see what it sounds like when I plug a guitar in real quick. While it's not as pretty to look at on the video with this metal plate in place, it gives me an expectation of what it should sound like through the cabinet. That little bit of scratchiness, it's a pot on this guitar, and there's some hum because I'm sitting within a foot or two of the transformers. All right, tomorrow I'll do the real playing test, and we'll see if the output tube microphonics are a problem with the speaker or not. Before, I was getting all kinds of stuff that turned out to be those grid wires that we just replaced. And, you know, I'm trying to change only what's necessary and leave as much vintage as possible. In that next video, I will have replaced the speaker wiring in the cabinet, which I mentioned before was messed up. I'm not going to do a video on that, but I'll show a picture of it with the playing test. And hopefully these old RCA 606s will make the grade even with that microphonic one. If not, we'll have to get some new tubes, but I'm trying not to spend the client's money just willy-nilly.